You know, when you see a demo of an AI transcription tool, it feels like actual magic, right? But taking that magic from a simple demo to a robust, production-ready system that's serving thousands of users in real time, well, that's a completely different challenge. So let's pull back the curtain and really unpack what it takes to make AI audio work at scale. And it all starts with these absolutely mind-blowing models, like OpenAI's Whisper. I mean, we're talking about technology that hits human-level accuracy across dozens and dozens of languages. Just let that sink in for a second. This isn't some small improvement. It's the fundamental breakthrough that makes everything else we're about to talk about even possible.
And here's the core of the issue, right there. The AI brain is brilliant, no doubt. But turning that brilliance into a real product that works flawlessly for everyone, everywhere, without completely breaking the bank, that's the real beast you have to tame. It's this massive chasm between a cool party trick and a truly viable business.
And look, the potential here for business, it's massive. We're talking about transcribing entire broadcast archives, creating live subtitles for a global audience, making huge libraries of media instantly searchable, and of course, powering the next generation of voice assistants. The potential is just enormous. But here's the big question, the one that trips almost everyone up. What happens when you actually try to scale this thing? Suddenly, the simple, elegant pilot project just hits a brick wall of real-world problems. And those tiny little cracks you never even noticed with just one user, they become catastrophic failures when 1,000 people all log on at once. Okay, so problem number one is latency, that awkward delay. A typical AI system has a delay of anywhere from 450 to 750 milliseconds. Now, that might not sound like a lot, but believe me, research shows anything over 300 milliseconds just feels unnatural to us humans. It's that awful pause on a video call that makes you start talking over each other. It totally shatters the illusion of a real-time conversation. And then, problem number two, the sticker shock. Oh boy. As these AI workloads get bigger, the public cloud bills can just spiral completely out of control. We've heard stories of teams seeing costs explode by as much as 20 times what they planned for. 20. It just becomes financially impossible really, really fast. All right, and then there's a problem that's basically as old as the internet itself, packet loss. I absolutely love this analogy here. Think of your audio data as a fleet of tiny cars driving down the highway. When there's a lot of traffic, network congestion, you get a massive jam. And in all that chaos, some of those cars, they just disappear. Poof, they never make it to their destination. And the result of that? Well, it's all the stuff we absolutely hate as users. Those lost packets are why you get that constant buffering wheel spinning. It's why your video quality suddenly drops, or why you get those super annoying audio-video sync issues where someone's mouth is moving, but you don't hear the words till a second later. It's just so frustrating, and it kills the experience. So what this all boils down to is what we call the AI reality gap. On one hand, you've got your pilot project. It's all simple API calls, predictable costs, low volume, no big deal if it glitches. But then you hit production reality. Now we're talking complex, real-time streaming, totally unpredictable costs when you scale, massive volume, and now it's absolutely mission critical for your business. So the big question is, how do we actually bridge this gap? Well, I can tell you it's not about finding some single magic fix. There's no silver bullet here. The real solution has to be a full stack approach. You have to tackle the problem at every single layer. The AI model itself, the network it runs on, and yeah, even the physical infrastructure that powers the whole thing. Okay, so step one, we've got to roll up our sleeves and optimize the AI model itself. And this isn't just one tweak, it's a whole series of smart decisions. You have to pick the right model size. You know, that classic trade-off between speed and accuracy. Using powerful GPUs, that's just non-negotiable. And this is huge. You have to use optimized versions, like faster Whisper, that can process audio in tiny, real-time chunks instead of the default 30-second blocks, which, by the way, are just killer for latency. Okay, next up, the network. You'd be surprised how many systems are still running on these ancient protocols like RTMP. I mean, they were designed for a totally different era of the internet, one where this kind of real-time, two-way stuff just wasn't a thing. They're like a delivery driver who just gives up if they hit a little traffic. They can't recover those lost data packets we talked about. And that is what leads to that dreaded buffering wheel. But modern protocols like gRPC, they were built for this. We're talking 50 to 70% lower latency. It's a total game changer. And that brings us to the final piece of the puzzle, and honestly, maybe the most strategic one of all, the infrastructure. Because it turns out, where your AI runs is just as important as how it runs. This isn't just some techie detail, it's a massive business decision. And this is where you have a really big choice to make. On one side, you have the public cloud. Yeah, it's accessible, but you're dealing with unpredictable costs, and your performance can get bogged down by what we call noisy neighbors, basically other people hogging the resources on the same shared hardware. But on the other side, you have a private GPU cloud. That gives you dedicated, bare metal performance. Think of it like having the entire highway to yourself. No traffic, nobody else to slow you down. And you get predictable costs, and this is so important, complete control over your data and your security. And hey, don't just take my word for it. The engineering lead at OpenMetal puts it perfectly. They said public cloud GPU access is just riddled with limitations. You're paying premium prices for throttled performance, all on infrastructure you don't even control. It just doesn't add up. You know, this whole decision is actually part of a much, much bigger trend that's happening globally. Companies and even entire countries are moving toward building what they call sovereign AI capabilities. People are finally realizing that if you don't control your own compute infrastructure, you don't control your future. It's really about owning your own destiny. And the scale of this is just mind-blowing. Take a look at Reliance Jio in India. They are investing 10 lakh crore rupees. That is over 100 billion US dollars just to build their own AI infrastructure. And why? Their chairman, Mukesh Ambani, he said it best. India cannot afford to rent intelligence. They see this as a foundational national asset, not just a service, an asset. So this all leads to one final critical question that you really have to ask yourself. Is your AI strategy being built on rented land? You know, where you're always subject to the whims, the rules, and the price hikes of a landlord? Or are you investing in a permanent, strategic asset that you truly own and control? Because honestly, the answer to that question is going to define who wins and who gets left behind in the years to come.